This lesson is about writing linear equations. This is a very important section, one that you will use really all the way through calculus. It's used a lot in calculus. It's covered in Algebra 1, is where it's introduced. A typical geometry class spends a decent amount of time on it as well. And then in Algebra 2, it'll be reviewed again. But it's something that you should know coming out of Algebra 1, so I'm going to spend a little time on it here. I'm going to go through kind of the three types of examples we typically see. The first is kind of our favorite example, the easiest, and they'll get progressively hard here in these three. The first is where the slope and the y-intercept are given. So let's say someone just says, hey, tell me the equation of a line where the slope is -2 and the y-intercept is, let's just say 5. Writing an equation of a line, typically we want it in this form. This is what I like. Some people like other forms, but this is what you're going to see most of the time, y equals mx plus b. Well, guess what? They gave you the m, and they gave you the b. This is m, right? Let me write this different color. This is the m, and this is the b. So there's not much to it. You're just going to say it's y equals, not m, but m is given as -2, so -2x plus b, but b is given as 5, and you're done. Not much to say more about that one. Okay, next example, a little more involved here. They're going to give you that it's passing through a point this time. Maybe, what's the equation of a line that passes through the point 4, -3, and has a slope of -1/2. At this point, it might be worth making this a little side note if I have room. Yeah, let's do it here. You need two things to write the equation of a line. Sometimes I make a big deal about this, so I'm going to do it here, off the side here. Two things are necessary to write a, sorry for my handwriting here, to write a line equation. First is you need a point. Not, it can be any point on the line, of course. It can be any point. That's why I wrote the word A. A is not an exclusive word. There's an infinite number of points on the line. You just need one of them. Secondly, you need the slope. The is an exclusive word. There's only one slope for a line. The line has a constant slope. You need to know what that is. Those are the two things you need to know. So when you're doing these problems, you might think of yourself on a mission to find these two things. The first problem, well, they gave you the slope, and they gave you a point, not just any point, but a very convenient point, the y-intercept. That was pretty nice. This one, they give you the slope, and they give you a point. So neither of these our mission is very exciting. We get what we need right away. I'm going to erase this because I have a feeling I'm going to run out of room if I don't. Let's erase this. Okay, so there's really two ways to do these, and I'm kind of going back and forth on which way I should show you. I think I'm just going to show you both, and you'll probably pick one you go with. And I'll give you a little background to these two techniques too. First I'm going to show you really what I would say is the Algebra 2 technique. We have time for this, so, you know, we got all the time in the world really. So I'm going to show you the Algebra 2 technique, and then I'll show you what's typically taught in Algebra 1 class. If you want to stick with the Algebra 1 technique, that's fine. Usually your Algebra 2 teacher and beyond might prefer using the more sophisticated technique, maybe we could say. So let me show you that first. The sophisticated technique is using what's called the point-slope formula. Point-slope formula. And the point-slope formula is this: y minus y1 equals m times x minus x1. And I could probably tell you, if we had time, about how this is real similar to the slope equation. If I divided both sides by x minus x1, it looked just like the slope equation, but that's not really that important. So let's use this point-slope formula first. All you're going to do is just plug in the points. So the point that it passes through is your, let's change colors here. This is your typical x, y coordinate. So the x is your x1 and the y is your y1. Those subscripts tell you that those are specific, particular, single points. The x and the y that don't have the subscripts, those are variables. Those are changing values. We don't want to plug in for those, at least long term. So let's plug in. For my y1, let's change back to a different color. For my y1, I'm going to put in -3. For my m, that's m, right? Put in -1/2. And for x1, I'll put in 4. Well, you might recall that when you subtract a negative, it's a plus. You could argue this is the right answer. This is an equation of a line, but I like to put it in y equals mx plus b. So let's distribute the -1/2 over here, -1/2 x, and then -1/2 times -4 will be +2, right? You're distributing to both of these. I am running out of space, so I'm going to move over here. Finally, I'm going to subtract 3 on both sides, and I end up with y equals -1/2 x minus 1. So when I subtracted 3 on both sides, you might think, hey, did you not subtract it by the other terms, like by -1/2 x and by y? I subtracted on both sides. I just combined like terms. On the left side, the like terms became 0. The y remained, though. And on the right side, the like terms were the non-x's, the constants. So 2 minus 3 is -1. So I didn't do anything wrong there. And that is our equation. Let me show you. You might be not liking this technique, and if you don't, for the time being, you'll be okay. You'll be okay doing it this way. So let me quickly review what we had there. We said passing through 4 -3, and the slope we said was -1/2. Let's kind of take a quick note there. The other technique is saying, I love y equals mx plus b. I want to use it as much as possible. And so this is the other technique that you probably learned in your Algebra 1 class. You say, hey, this -3, it's a y coordinate. This was given as a slope. Hey, this 4, it's an x coordinate. So what I've done is I have an equation that only has the y-intercept as our unknown. And if we want to put it in y equals mx plus b, all we need is the slope and the y-intercept. We already have the slope. It was given as -1/2. So really we're on a search for the y-intercept. This is the rationale. This becomes -2. Add 2 to both sides, and you get -1 as b. Well, the other equation, when you get there, you're done. This one, you have one more step, and it's to plug in. So you say y equals -1/2 x. I was given that was my slope, minus 1. That is my calculated y-intercept. This way is fine. You can do it this way if you like. Okay, one more example. Finally, I guess you could say, most challenging problem that you can encounter, I guess in algebra at least, Algebra 1, is the one where they give you 2 points that the line passes through. So let's say we want to write the equation of a line passing through the points -3, 4, and and 1, -8. Okay, well, it makes sense to go back to our original thoughts. To write the equation of a line, you need 2 things. You need a point. Check. I got a plethora of points, right? We got 2 points. We got plenty of points. No problem there. I also need the slope, the exclusive one and only slope. Oh, they must have forgot to give me the slope. Let me look at my notes here. No, I'm not giving you the slope. So you say, how can I do this problem? All I have are 2 points. How will I ever get the slope? And you realize, wait a second, this slope equation, we've been doing this a long time. I haven't reviewed it in any of the lessons that I've done here yet. So we'll review that now. Slope, I did mention, I guess earlier, is rise over run. So rise really, let's write out a few slope things here. Rise is your change in y value. And run is your change in your x value. So that's how I remember slope. I don't remember this y2 minus y1 over x2 minus x1 stuff because it's easy to get mixed up. If you think of rise over run, or change in x over change in y over change in x, I think it's a little bit easier to keep straight. So to find the change in the y, we're going to say, well, y was 4 and now it's negative 8. So what kind of change was made? Let's imagine that you were making a job $5 an hour and you got a raise and now you're making $8 an hour. The change is 3, right? It's 8 minus 5. You do the new value minus the old. That's what we're going to do. Negative 8 minus 4 is the change in y. 1 minus negative 3 is a change in x. That's going to be negative 12 up top. And just to make sure I don't make a mistake, I'm going to go ahead and change that to plus. 1 minus a negative, or 1 minus negative 3 is like 1 plus 3. So this becomes negative 12 over 4, which is indeed negative, am I going to run out of space here? Negative 3. Okay, so now I do have the slope, and I have 2 points. Tricky part here, which one should I use? Doesn't matter. Doesn't matter which one you use. So I'm going to use my, oops, sorry about that. I don't know why that. Okay, I'm going to use my my point slope formula to say y minus, I'll just pick the first one, y minus 4 equals negative 3 x minus negative 3. So I always recommend before you start moving the 4 over, deal with the right side first, distribute. So that becomes a plus. This becomes negative 3x minus 9. In other words, when you add 4 to both sides, you get y equals negative 3x minus 5. There's your answer. I'll go to the back, I'll go to the next page and quickly do this with the old school y equals mx plus b too. But I'll let you take a look at that before I move on. Okay. So we were at the point of saying the slope, what was the slope? Slope was negative 3, and I'm just going to use that same point, negative 3, 4 again. So if you use this method, y equals mx plus b, you say, hey, 4 is a typical y, slope's negative 3 is a typical x, and I want to find b. Negative 3 times negative 3 is 9, subtract 9, negative 5 is b, so my equation finally is y equals negative 3x minus 5. That's the other way of doing it. Okay, hope that helped you in writing linear equations, a very important topic. And you know, you will spend some time in geometry in this again, but I think it's important enough to spend some time on. Hope this helped.
Made with Doodlecast Pro.